Today is Friday, June 3rd, 2026. Welcome to This Week in Natural Refrigerants News, where we recap the top stories on naturalrefrigerants.com. This podcast is generated and read by artificial intelligence and may contain errors. We're your hosts, AT and MO, and the articles for today's podcast were organized by naturalrefrigerants.com's managing editor and written by its writers. You can find links to each article in the show notes. Diving right in, what if I told you that even with all these strict regulations on synthetic car refrigerants, we are still locked into dumping over 100,000 metric tons of forever chemicals into the environment?
Yeah, I mean, that's exactly the pretty grim reality outlined in this new report from Hannon Systems.
Yeah.
They went and quantified the European TFA load, specifically from HFC 134A and HFO 1234A in auto air conditioning.
Yeah.
And, we're already looking at 68,000 metric tons accumulated by 2025.
Wow. So it's kind of like steering a massive cargo ship, right? Because these vehicles stay on the road for, 15 years or more?
Yeah, at least, yeah.
So the refrigerant choices we made a decade ago are still driving these huge accumulations today. Even if the industry hits the brakes on F-gases right now, that historical momentum means we're locking in massive PFAS loads anyway.
Exactly. And the projections without new regulations are just severe. They're talking about hitting 240,000 metric tons by 2058.
Right. 240,000?
Yeah. And even if we model the absolute strictest regulatory scenarios, with zero exemptions, the data shows we're still locked in for 102,000 tons.
Yeah.
And that wouldn't even peak until around 2036.
Wow. And for those of you wanting to dig into the methodology there, Atmosphere will actually be hosting a webinar to discuss these findings later in June.
Right. Definitely worth checking out.
But, if we're going to avoid that 2036 peak, the transition to CO2 and R290 maybe just has to happen now. And we are actually seeing that hardware reality take shape, right now over in China.
Yeah, Sandin is currently co-developing an R290 integrated thermal management system for EVs, and they're doing this with a major Chinese automaker.
Okay, so how are they handling the safety aspect with propane?
Well, they're using an indirect setup. So they separate the coolant and the refrigerant circuits. It's a really smart architectural choice because, it directly addresses that primary safety hurdle.
Oh, right.
It keeps the propane completely isolated from the passenger cabin.
Which makes total sense. And China has that aggressive July 2029 ban kicking in for refrigerants with a GWP over 150.
Yes, they do.
So with companies like Sandin locking in these mass production partnerships over there, do Western OEMs risk finding themselves completely outpaced on component maturity?
Honestly, it's a highly likely scenario. The Chinese market is kind of functioning as this massive incubator for R290 EV components right now.
Yeah, that makes sense.
So Western OEMs could very easily find themselves playing catch-up on supply chain maturity when domestic regulations inevitably tighten up.
Right. And, that push for massive scale isn't just happening in tiny EV components.
Yeah.
Look at the commercial sector in the UK. Aldi just opened a 1.2 million square foot distribution center in Barton.
Oh, wow. 1.2 million. That's huge.
Yeah, it's massive. And it's running entirely on an 8.6 megawatt CO2 refrigeration system.
That's a ton of cooling power. It's across, 11 systems?
Exactly. They've got 1 megawatt for low temp, 7.2 megawatts for medium temp, and 380 kilowatts for high temp.
But they aren't just pushing raw cooling power there, right?
Right. The engineering focus is really on closed-loop efficiency.
Yeah, they are reclaiming heat directly from the plate heat exchangers and then routing it straight into underfloor glycol heating mats.
So they're squeezing out every drop of efficiency to get this zero-waste thermal loop.
Exactly.
And, taking that concept of heat recovery even further, Caverion is commissioning this monumental district heating project in Kajaani, Finland.
Right, flipping the script from massive industrial cooling to large-scale municipal heating.
Yeah. They're bringing online the first 12 megawatts of a planned 30-megawatt Fenergy heat pump system.
And this is really clever because they're taking waste heat from local data centers, which, sits at a very low 30 degrees Celsius. And they're using R600A and R290 compressors to boost that up to 85 degrees for the city's district heating network.
That is a huge jump.
It is. And operating at a COP between 4.2 and 5, it's just incredibly efficient.
Covering 80% of a city's annual district heating demand is huge. But I have to ask, doesn't tying baseline municipal heat to private data centers make the public grid, dangerously reliant on tech sector stability.
Well, tying critical public infrastructure to private server loads definitely carries some structural risk, sure.
Mhm.
But the system retains the original synthetic chillers for redundancy. Plus, the local energy providers were heavily involved in the early power planning to, mitigate that exact vulnerability.
Oh, okay. That makes me feel a bit better about it. So if you could harness hydrocarbons for an entire city grid, the next logical frontier is kind of dropping that tech straight into individual homes, right?
Right, downsizing it.
Yeah.
And that's exactly what NewSco is doing. They're a UK startup testing a tank-integrated R290 heat pump that's designed specifically to replace residential gas boilers.
So this directly targets the retrofit market then.
Exactly. By integrating the thermal storage and hitting outlet temperatures of 65 degrees Celsius, it matches the exact output of traditional, dirty gas boilers.
Oh, so homeowners don't have to rip open their walls to install those massive, oversized radiators that standard low-temp heat pumps usually require.
Right, exactly. It's a huge barrier removed for adopting natural refrigerants in homes. They actually have prototypes running in Bristol right now, and they're aiming for a commercial launch in early 2027.
Wow, 2027 is coming up fast.
It really is.
This is ATNMO, and this has been the Week in Natural Refrigerant News.